I'll be covering the topic of repair and rehabilitation of aircraft operating pavement surfaces. Firstly, I will brief you about the importance of military airfields. Now, coming to the distress in rigid pavements. Rigid pavements are also part of military airfield, and all the taxi portions and all the link portions are made rigid because the speed is not very much high in these portions. Hence, the rigid pavement are made because they require very less maintenance. Although the initial cost is very high, but the maintenance cost is very low. First distress is the map cracking. Here you can see a minor map crack, here you can see a moderate map crack, and here you can see severe map cracks. Map cracks basically they are formed due to temperature stresses or inadequate subbase. They may be ignored if the thickness, if the width of this crack is less than 0.5 mm, and if the severity is high and the width of the cracks are more, then they should be repaired with the elastomeric material, or the slab has to be replaced. In case the width increases with time, the complete slab has to be replaced then. Second is the potholes, or you can say the pop-outs. You can see minor pop-outs, and here you can see a pothole, small pothole. They generally occur due to the foreign material and chemical reaction within the concrete mix, admixture, cement, aggregate and water. To avoid such potholes, the aggregate material should be tested for durability and petrography test should be ensured during the execution of this rigid pavements. To ensure a sample trial slab has to be done for bigger projects so that we can compare that what are the conditions on the sample slab and what are in the actual slab. These small potholes and pop-outs, they can be repaired with the epoxy mortar. Again, these potholes should be repaired immediately to avoid any FOD on the aircrafts. Now, coming to next are the pavement joints. Joints are the integral part of rigid pavements. Basically, joints are the artificial cracks which are induced in the rigid pavement, and if these joints are cut in irregular fashion, then the slab will fail in irregular shapes and irregular patterns. A crack has formed near the pavement joint. You can see a crack. The reason behind this crack is the misalignment of this joint. You can see the joint is misaligned and not in a straight line. Hence, this crack has formed. Coming to the second picture, you can see again a misaligned joint in the slab. What will happen is this misaligned joint will ultimately form a new crack in irregular fashion. Here you can see a joint has not been cut within the timelines. What has happened is a small portion of edge has started to crack. So to avoid all these, the joints should be cut in proper alignment and they should be cut within timelines so that no cracks are formed beyond these artificial joints. Again, you can see a small crack which has formed very near to the expansion joint. Here you can see a small crack which has formed along the length of the slab. Here you can see a small crack which has formed very near to the artificial joint, this artificial joint. Again, in this pic you can see a crack which has formed very near to the expansion joint. The main reason behind this crack formation is the late cutting of expansion joints. The timelines for the expansion joint cutting should be 8 to 12 hours. All the expansion joints should be cut within these timelines as per the MOTH guidelines to avoid such type of cracks. If at all these cracks are formed, this can be repaired easily with elastomeric material and epoxy mortar that we will cover in next slides. Again, these slab cracks, they occur due to many unknown reasons, but these can be addressed properly with the epoxy and elastomeric material. These material have very high strength and quick setting properties. In case the cracks are more and the width is more, then complete slab should be replaced. Here you can see a slab has been replaced, and here you can see elastomeric material or epoxy mortar has been used to repair this crack. Again, a few corner and edge cracks, you can see a corner crack which has been repaired by the epoxy material in this fashion. Corner and edge cracks, again they are formed due to the temperature stresses, concentrated point load or insufficient support of subbase. Partial or full depth Concrete patching can be done with epoxy mortar or elastomeric material. Again, few pics of corner and edge cracks. This very small portion of the edge crack has been repaired. Then very neatly done edge crack nearby the expansion joint, and then very neat slab replacement of the slab crack. Then the most important point is the joint faulting. Joint faulting, these may occur due to settlement of adjacent slab, creating a dip in the joint, thereby reducing the riding quality. What happens is, with time, the joint forms a dip between the two slabs. A joint, you can see a joint here, and you can see a dip between the two slabs. What will happen is, this dip in the joint will reduce the riding quality, and the passengers or the aircraft will feel the bumpy ride. To check these, in fact to measure this joint dip, a bump indicator equipment has been approved by the MORTH, and the minimum requirement should be 1800 mm per kilometer. It should not be more than this 1800 mm per kilometer as per the IRC SP82 code. These joint dips should be avoided in the high speed zones of the pavement surfaces. Again, few pics which are depicting methods of crack repairs. Here you can see a small crack which has been repaired by the epoxy material. Here you can see a portion of slab which has been repaired by the epoxy material up to partial depth. Here you can see a crack repair which has been done with elastomeric material. Here you can see a partial slab replacement. Here you can see a complete slab replacement, and again edge repair which has been done with the epoxy mortar. These epoxy and elastomeric material, they are very quick setting and they have very high strength. That's all, my viewers. Thanks.